I hope you're practicing this stuff on your own. They say practice makes perfect. I'm going to illustrate that now by me recording this for the second time. About halfway through this, my microphone turned off, and I did not know it, and so I get to do it all again. But that just means you guys get a better presentation here, and maybe it'll be a little bit shorter than my first one. All right, so I want to do distribution of the sample proportion. Changing a word. That's not the sample mean, it's the sample proportion this time. So instead of taking an average of things, I guess we did average of pennies on the last video. We're going to be just doing a proportion, maybe the proportion of pennies that were minted after 1982. So we're looking at a few more decimals in this video. So, two objectives from this video is to be able to describe the sampling distribution of a sample proportion. I'm still wanting to do shape, center, and spread, the three S's on that. Okay, so that's not changing. And then I want to be able to compute the probabilities of a sample proportion. Same as we did on the last one, we just have a few little tweaks we have to make. So first up, they're not going to always tell me what my point estimate is or what my average is. I'm going to have to find it myself. And so I'm going to have to be able to find my sample proportion, which I'm going to denote with a p hat. Yes, that is a p hat. It's a p wearing a cute little hat, like a party hat or something. And I'm going to be able to find that by just taking my x, which is the number of individuals in the sample with a specified characteristic, or maybe they don't have one, and dividing it by n, which is the total number of people in my sample. So let's try this. This is as easy as it looks, I hope. Quinnipiac University poll conducted in May of 2008. 1,745 registered voters nationwide were asked whether they approved of the way George W. Bush is handling the economy. 349 responded yes. I just want a point estimate for the proportion of registered voters who approve of the way W. Bush was handling the economy. If I'm just wanting a point estimate, that's just my P with a little hat on it. And I'm just going to take the number of people that have a characteristic, the number of people that do approve, which is the 349. I'm going to divide that by the total number of people that were in my survey, 1,745. And that gives me pretty close to 20%, 0.2. Now, my goal with this is hopefully I was able to get this number large enough to make it so this mimics what the actual proportion is of all registered voters. There's no way I can get my hands on every registered voter in order to do this sample. So I'm hoping that I got that large enough where this 0.2 mimics what the true proportion would be, which is just P without a hat. We'll just call it P. Don't say without a hat. All right, example 2. According to a USA Today poll, 42% of people would not live in a haunted house. I would not live in a haunted house. Around Halloween time, a lot of my friends say, hey, let's go to this haunted house. Let's go to wherever that place is down in Arkansas. And I'm like, nope, I like to sleep too much. And so if I go there, I wouldn't sleep for a week. Just don't like that. Kudos to those people that do. It sounds like a lot of fun. And I want to describe the sampling distribution. Okay, so I'm just going to kind of show you again, like I did with the pennies, except for I'm going to be using this haunted house. And I'm going to be using samples of size n equals 10, n equals 50, and n equals 100. So let's look at the n equals 10. This is going to be whenever I ask 10 people how they feel about haunted houses. All right, I got about 42% of them said that they were for it. I got my standard deviation. Don't worry about how I found that number. I'm going to show you in just a little bit. I'm not going to keep that secret from you. What I wanted to just point out on this was, not exactly normally distributed. I would say that's closer to being skewed right than being normally distributed. And so I probably need to change my N a little bit and hopefully get something normally distributed so that I can be using what we have been doing in class. So I'm going to up it a little bit. N equals 50. Oh, that's better. Ooh, look, I don't have nearly as much spread on this. Everything's kind of pushed into the middle a little bit more. And check it out. A lot more normally distributed. I like that. So something happened between n equals 10 and n equals 50 that made it so it followed a normal distribution a lot better. And if I go up to 100, yeah, even better on that. All right? And so here's what I want you to get from it. First up, the shape. On the shape, as n increased, then the sampling distribution became more and more normal. So my goal with this is to get n to be large. What's large? I don't want to say bigger than 10 on this one because that's not always going to be the case. But I'll tell you, for the examples you're going to be doing, the examples we're working in this video, the practice problems I'm going to give you, and on the assessment, the n is going to be large enough to be approximately normal. So you don't have to worry about that. The center, all right, the mean of the sampling distribution of the proportion is going to be the population proportion. So I expect it to be 42%. It still came out to be 42%. And then the spread, all right? Notice that on all those histograms that I made, the spread got closer and closer and closer together. It decreased as my n increased. So here's some formulas for you. First of all, I'm not going to worry too much with this, all right? Ideally, if I was to plug in my n and my proportion and everything, I get it greater than 10. That's how I know it's approximately normal. I'm going to tell you, n's going to be large enough that this is going to be automatic. So don't worry about that, all right? And especially with us learning this from home. The mean is simply going to equal the population proportion. So that's good news. It doesn't change any, okay? And the standard deviation, I got a new formula. Now, this formula, I am not going to expect you to memorize. Of course, you're not going to memorize it when you're at home because you're at home and you'll have your notes and whatever you need to take this. But even if we come back before the next assessment or before the final, this is going to be on your formula sheet. It will be on the board. I don't expect you to have it memorized. I just expect you to know how and when to use it. And that's how I was coming up with my spread and the standard deviation on the haunted house problems. Okay? So let's change my number on the haunted house problems. Don't worry too much with this slide. I talked about it in the last video, and I wish I didn't. And so pretty much it just says you have to have independence on this and a large sample. And whether you have a large sample or not, this sampling, this standard deviation is going to hold true. So nothing we're going to really worry about this year. So let's go back to the 42% of people who would not live in a haunted house. I'm going to get a sample of 50 of them, all right? 50. And determine which people would not live in the haunted house. I want to describe the sampling distribution of the sample proportion for people who would not live in a haunted house. So this should be pretty straightforward on this. And again, I want my 3 S's. I want my shape, I want my center, and I want my spread. And yes, I misspelled center on purpose, so you can kind of see it. Okay. Now my shape. We're just going to keep it easy this year. 50 is a large number. It's a lot larger than 10. And if I was to plug it into that little formula I had, everything's going to work great. And so since 50 is a large number, then the shape is going to be, let's throw that word approximately in front of it again. Approximately normal. Okay, it's never going to be perfectly normal. I'll throw that word approximately in there, and that kind of covers me. Okay? The center of this. The center is going to be my mu sub phi hat. Okay, so the center of this should be that 42% that they gave me in the problem. The spread. Notice nowhere on here it talks about standard deviation. That's a little bit different than what we had in the last video. So the spread on this one, I need to come up with all the numbers myself from this 0.42. And so my spread is going to be this sigma sub p hat equals, I'm just going to do the square root of people that would not live in a haunted house, and I'm going to multiply that by the people that would live in a haunted house. Well, I know that's going to be 58%, and I got that by just doing 1 minus 0.42. And I still divide by the square root of n. In this case, my n is 50, so I'm going to divide by the square root of 50. The square root covers the bottom, so I'll end up taking the square root of all of that. And that gave me 0.0698. That would be my spread. I am describing the sampling distribution. 3 things on it: shape, center, and spread. And that would be full credit. Alright. CDC has been all over the news, of course, with everything that's going on. So I've been doing this example for years, and just so happens to fall during this week. According to the CDC and Centers for Disease Control and Prevention, 18.8% of school-age children between the ages of 6 and 11 years old were overweight in 2004. Now, the first thing that kind of sticks out to me is that was a long time ago. Keep that in mind for about 5 minutes from now whenever we're wrapping up this problem. So in a random sample of 90 school-age children, I want to know the probability, have those Z charts ready, your normal distribution charts, that at least 19% are overweight. I'm going to go ahead and get all my numbers that I need for this going forward. All right, I'm going to put them out here to the side. So I want my shape, center, and spread. Now, I did 90 school-age children. That's a lot. That's a large sample. All right, much bigger than 10. I like stuff that's much bigger than 10. So I'm going to be approximately normal on this, on my shape. Now my center is not going to change. I'm expecting to get this 18.8%. But the whole reason I'm doing this is because I want my spread. It doesn't say anything about spread on here, and I'm going to need to go to my Z chart on this eventually. So I'm going to need my spread in order to know what number to get from my Z chart. And so my spread is going to be, I did this on the last video. I didn't leave myself enough room. Let's just pull that over. So this is going to be important. I'm going to take the number of children that were overweight and the number of children that were not overweight. And I'm going to multiply those together. Not the number. I said number. I shouldn't have said number. It's proportion. And I'm going to divide that by my n this time. And so this gave me a spread. When I'm dealing with 90 children, it gave me a spread of 0.041. We'll see in just a minute where I need to use that. Okay. So I did all that preliminary. I did my shape, center, and spread. That's just something good to get out of the way. Now I'm ready to tackle part A. All right. I want to know the probability that at least 19 are overweight. At least 19%. I keep leaving that off. So I expect to get 18.8% to be overweight. But I want to know the probability that I get, so here, this line right here is my 19%. I want to know the probability that I get at least 19%. So I want to know the probability that I get something bigger than 19%, something over here. Well, first thing I need to do is I need to normalize my data. All right, so I need to get me a Z-score for it. Now, if you're using a graphing calculator or the graphing calculator app on your phone, you can just go straight in and plug these numbers like we showed last week. But I'm willing to bet most of you are going to be using a table, so I'm going to need to normalize all my data first. Now, I'm going to divide that by the standard deviation. So this is where this 0.041 is going to come into play. And so that gives me a Z-score of 0.05, really small. Remember what that means. That's not my percent. That's how far away I am from the center. I am 0.05 standard deviations away from that center of 18.8. That's not very much, so I'm expecting something close to 50% on this. So to answer the question, I'm wanting the probability that my p hat, the probability that the proportion, oh yeah, that p hat would be at least 19%. At least 19% would be p hat being bigger than 0.19. And so to get that, I've got to pull out my z table. All right, let's see if I can get out of this. I can go to the next slide. Yeah. Hey, I'm almost done. That's good news. So my z-score is 0.05. Let me expand this so we can all see it. 0.05. Got some marks on it from last time. Be careful, this is going to be kind of weird, and you can't see the top of it. I apologize, but 0.0, I'm actually going to be using this line, and if I count over to 0.05, that's 0.00, 0.01, 2, 3, 4, right here. That 0.5199 should match up to this. So let's go back and put that in the problem. The 0.5199, remember z-score and that chart, they are in love with the left side of that chart. So that 0.5199 is all this area that is over here to the left side that I did not shade. So to get my hands on the part that I did shade, I want to do the 1 minus 0.5199. And so that gives me 0.4801. I'm expecting about 48% of the time I will get a probability of at least 19% of children being overweight. There are a couple of ways I can ask this. Let's look at another way I can ask this, and let's use a little bit different numbers. The way we just did it, I call it the nice way. I told you 19%. Okay? What if you had to come up with that number on your own? Suppose you did a random sample of the 90 children, so that way I'm not changing any of my numbers over there on the side, and I got the results to be 24 overweight children. There's no proportion there at all. I got to go back to that George W. Bush problem and come, like I did in the George W. Bush problem, and come up with my own proportion. So I'm going to do my proportion. I'm going to do 24 divided by 90, and I believe that gives me 0.2667. Double check, yes. Wow, almost 27%. So 26.67%, that is a long way from 18.8. So it just says, what might you conclude? That's not enough to conclude anything, but let's go ahead and do all the math that we just did, and let's get the probability of getting something that extreme, okay? Because I expected to get something really close to this, according to the CDC. But I got something way over here. How far away is that? Well, I need to normalize my data again. 0.2667. Just doing all the same math I just did, except for I'm using a different number. I'm using the 27% that I found. And I had the 0.041. And whenever I find that z-score, that gave me 1.91. Meaning I am 1.91 standard deviations away from that center. That's kind of a long way. Let's see the probability of me getting something. Look how there's not much room over here. Let's see what that probability is for me to get something way over here in the tail of this curve. So I'm going to go back to my Z chart. Let's see, I got 1.91 I'm going to be working with. It's probably going to move again, of course. Z chart, 1.91 this time. Oh man, I didn't fit it on here. I'm gonna have to move it up. I thought I had enough room. There we go. We should be able to see that. 1.91 should be here. 1.90, 1.91. That is super blurry, but I do believe that is 0.9719. 0.9719. Let's go back and put this in our problem. 0.9719. Remember, it likes the area to the left. So 97% of the time, if the CDC was right, I should get something less than that. Meaning that this area that's above the line, if I do 1 minus that, it's just going to be 0.028. Since this number right here is less than 5%, what I conclude is if I get anywhere over here in either this tail or this tail, such that there's less than 5% over there, I conclude that something weird is going on, and I just call it unusual. Okay? In statistics, anything that happens less than 5% of the time, we are going to call it unusual. And we're going to be able to build off this in coming chapters. The fact that, remember I said 2004, that was a long time ago? Maybe this 18.8% should be moved a little bit. Maybe it should be moved closer to my 26.67%. A lot's happened with 6 to 11-year-olds since 2004. We have a lot less of them participating in rec leagues. We have more iPads. We have more video games. So maybe this needs to be revisited and that 18.8% gets thrown out because we got something that's unusual. We start getting into hypothesis testing and confidence intervals, and it's all sorts of fun, and that's coming in later chapters. Right now, I'm just really interested in you finding these numbers and these z-scores, and we will go forward from there. Probably will have some questions over this. Have these ready for the Q&A. Again, I have a couple ways I can ask this. You need to practice both ways because you'll be assessed on this both ways.